So question 42, we've got a projectiles question. We're told that it's got a speed of 50 and it's got an angle of theta. So breaking this up, I've got a 50 sine theta there and a 50 cos theta going over here. And we're told that when it's projected, it goes 10 meters above the original starting place. Not going to worry about the 36 to begin with. So let's look at this vertically. U is 50 sine theta. The velocity v at the highest point there is 0. S is that 10 meters, and the acceleration is the minus 9.8 due to gravity. Minus because it's going downwards and everything else is upwards. So I'm going to use a v squared equals u squared plus 2as here. V squared is nothing. This one squared, so 50 squared is 2,500 and sine squared theta. And then I've got 2 times 10 times 9.8. I've got 196 there. So that given me sine squared theta is 196 divided by 2500. That gives me sine theta. I'll square root those. I've got 14 over 50. That's 0.28. And so theta I'm working out there to be 16.3 degrees. And you're not worrying about the negative square root. You're not worrying about the second version of the sine because those will be in different directions. So for part B, I'm actually going to think about putting this angle in. And so vertically, we've got 50 sine theta, and 50 sine theta is almost exact. It's 14, no, that bit is just 14.03 I've got there. Horizontally, I've got 50 cos theta. That's the one that is exact. That's 47.99. So I'm going to make that 48. And we're being asked to find out when is the speed the same as this again. Well, you know that horizontally the speed never changes. It's just going to be 48 all the way along. But vertically v equals u plus at. So I'm going to do 14 minus 9.8t. And there's my velocity. And the speed, well, you Pythagoras that, don't you? So we're going to do 48 squared plus 14 minus 9.8t squared, square rooted, equals, well, what we had there, 50 squared. Let's just take away here. So I've got 50 squared, take away 48 squared, gives us 196 again. So I've got two answers. One is 14 minus 9.8t equals 14. And that's nice because t equals 0. We wanted one answer to have a speed of 50 because it's the start. And the other one, 14 minus 9.8t equals minus 14. So I've got 20 there divided by 9.8. So I've got, whoopsie, that's a 6. 2.86 is the second time it happens. Now, look, I square rooted both sides. Clearly, you could have multiplied out the bracket and solved the quadratic, but I just square rooted. So continuing on to part C, we want to know the angle it makes, the angle the velocity of the particle makes with the ground at the instant it lands. So I'm going to need to know, well, when it lands. And I think to do that, I'm going to use an s equals ut plus half at squared vertically. And vertically, when it lands, it was going from there down to the ground. So I've got minus 36 here. U vertically, we've had earlier, was 14, isn't it? 14t, and then minus 9.8t squared. So I've got, what's that, 4.9t squared minus, actually that's wrong there, that's half a there, 4.9. So 4.9t squared minus 14t minus 36 equals 0. I'm getting the time it hits the ground is 4.49. The other one's irrelevant. And I think all I'm going to do now is put that in there. And so the velocity when it hits the ground is 48 and 14 minus 9.8 times by 4.49, and I'm getting that to be 30.03, I think. So we've got 48 and must be minus 30.03. What's the angle there? So I'll just do an inverse tan of that over that, and I've got 32 degrees for that. I suppose I'd add below horizontal, saying it's 42.03. Sorry, 32.03 I've got.